Hey everyone, this is Ms. Burko again. In today's video, we're going to do another quick review of solving equations. I know we talked about this in the 2.1 video, but this is just another chance to see some more examples in case there are any that you had questions about after last video. So again, the idea here is that we're working with an equation, and we can recognize an equation because equations always have an equal sign. So if we have something like x plus 3 equals 5, I can recognize that it's an equation because of that equal sign. So the other key here, besides recognizing when we have an equation, to know how to solve it, we need to know about inverse operations, which are just two operations that undo each other. And so we talked about this last time. So we can think of an operation, and each one has an inverse that kind of undoes the first one. So for example, if my operation is multiplication, its inverse is going to be division. And the opposite is true as well. For division, division's inverse is going to be multiplication. So then addition, its inverse is subtraction, and subtraction has an inverse of addition. So those operations will undo each other. So let's see how we use that to solve an equation. Again, when we're solving an equation, we use inverse operations to get the variable by itself. That's our whole goal. So when I see directions that tell me to solve the following equation, again, I know that my goal is to get the variable by itself. So let's go through some practice here on how we do that. So the first one, now this one's interesting because it looks like it's more complex, but here's what I want you to realize. If I'm saying 1a, that just means literally that I only have 1a, so that is the same as if I wrote a by itself. These two representations are equivalent, they're equal. So instead of writing 1a, it's much more simple if we just call it a. So to solve this, I'm just going to rewrite the equation as a minus 5 is equal to 7. So now I notice that the operation in my problem is subtraction. I need to use its inverse to undo it. So we said the inverse of subtraction is addition. So to solve this equation, instead of subtracting 5, I'm going to add 5, and I make sure to do that on both sides of the equal sign. So now when I do that, negative 5 plus 5 is 0, so those cancel, and I get a is equal to 12. And that's my answer. I got a by itself, which is what we said our goal was. So now, number 2, same idea here. My equation says 1x, but I know a way to represent 1x is just to write x. So now my equation really is just x plus 10 equals 30. So now for this equation, in my original, I'm adding 10. I know I need to undo addition, and again, I undo addition using subtraction. So instead of adding 10, I'm going to subtract 10 from both sides. 10 minus 10 gives me 0, so that cancels, and I get x is equal to 20. So that's my answer. All right, now in this case, here we have something a little different. This is telling me negative 1 times g is equal to 30. So this is multiplication. So now to undo multiplication, again if we go back to our list, we said if my operation is multiplication, the inverse is division. So here I need to divide both sides by a negative 1. And I show that by using the fraction here. That for us is going to mean division. So now I have the negative 1 divided by a negative 1. Those are going to cancel out. I'm left with g is equal to 30 divided by a -1, and that gives me a -30. Dividing by a -1, excuse me, changes the sign of my answer. All right. Now, on number 3, I have to be a little careful. If I know my goal is to get the variable by itself, the first thing I have to do is find the variable. Now, in this case, it just so happens that my variable is on the right side of the equation. So, that doesn't change anything, but now I know to get x by itself, right now, x is being multiplied by a -6. If I want to undo that multiplication, just like before, I see its inverse is, up here, its inverse is division. So now I'm going to divide -6 on both sides. So the important thing is here, when I'm dividing, I need to divide by the exact number and sign that was up top. So since there was a -6 here, I divide by a -6. Now these are going to cancel. I'm left with just x. And here I have to be really careful of my sign. So I would recommend using your calculator for this. So I'm going to type in my fraction. I have -42. On the bottom I have a -6, just like it looks on my paper. And if I hit enter, I get x equals a +7. Now, our answer looks a little different because our variable's on the right side, right? But that's okay. It has the same meaning as if we were to write it this way. All right, number 4 now. Number 4 is a little bit trickier. So what I see here is I have a fraction, so -2/5 times my variable b. So again, when I hear myself saying times, I know my operation is multiplication, which tells me that I can divide to get my answer. So one option for solving this problem is I can divide by a -2/5. Now, this will work. It looks a little messy, so it's not my favorite method, but we can certainly use division here to solve. So now those cancel. I have b is equal to, now I'm going to use my calculator to make sure I get this right. So I have 10, I'm dividing it by, and I'm going to put my fraction in here, a -2/5. So 10 divided by a -2/5 is going to give me -25. Now, that's one way of doing it. So what we ended up doing there is we divided by a fraction. But here's a little trick. Dividing by a fraction is the same as multiplying by a reciprocal. Or I should say multiplying by its reciprocal. So dividing by a fraction is the same as multiplying by its reciprocal. And if you remember, a reciprocal means we switch the numerator and the denominator. So here's what that would look like. Let's say I had the same problem again here. I'm going to give myself some space. So let's recopy number 4. If I had -2/5 times b equals 10. Instead of dividing by that fraction, I want to multiply by its reciprocal. So I'm going to use these parentheses to show I'm multiplying. The reciprocal means I take the same sign, so it's still negative, but instead of 2/5, I call that 5/2. And I'm going to multiply that on both sides, -5/2. Now, the nice thing about reciprocals is when you multiply them by each other, it just gives you 1. So these are just going to be 1. I'm left with a b. And again, I would use my calculator to calculate this. So I have 10. I'm going to use my parentheses to show multiplication. And then I have a -5/2. And I still get -25. So you can see that either way we get the same answer. It's just two different methods. Okay, now for the last problem. Here, I want to get my variable by itself. I see my x is over here, and I notice this -8 here. Since I have a -8, the way to cancel that, the inverse, is going to be adding 8 to both sides. And I can check that I'm right, because if I do -8 plus 8, I get 0, and those are going to cancel each other out. So now I just have x is equal to 12 plus 8, which gives me 20. All right, so I hope that was helpful for any of the problems that you still had questions with. And again, you'll get more chances to practice this in the Ready, Set, Go. Thanks and good luck.